Welcome to DeepSec. This is the left pirouette. I'm McLemmon. I'll be your session chair for this morning. We have already heard about the fact or fiction that coding securely is probably the same amount of work as just coding stuff. I'm not yet entirely sure about that. But since this talk is uncovering vulnerabilities in secure coding guidelines, there may be more depth to this. And so please welcome with me Fernando Arnaboldi.
Thank you.
Big round of applause, please.
Thank you. You're absolutely right. So, good morning, everybody. We're here to talk about uncovering vulnerabilities in secure coding guidelines. I'll tell you a little bit what are we going to talk today. We're going to talk about who may care about this, what I did, how I did it, and why you may care, or why may people care about this. Just a basic introduction of what this is about, and why eventually it would be a good idea to talk about this. I checked the following secure coding guidelines. Eventually I started with one. I saw that it made sense, and eventually continue with other ones, with some nice things that I came across. OWASP, the common weakness enumeration, and the search secure coding guidelines. All of them have different ways how they have been created, how they're being maintained, and how people use them. But overall, you can use them all to create products, people trying to use them to improve the security of their code, and eventually to check the security of other people's code. And I'm going to share what are the conclusions of this analysis. So let's start from the beginning, and let's talk about who may care about this. I believe that security consultants may care about this. I face this in different ways. As a security consultant, I've been using these type of things to check other people's code, to reference how they should be doing things. And people who develop software, ideally, they should be using this to know how they should be creating better software. And there are different ways of how people can use this. So you have the guidelines where you have people telling you you should be doing this, and that. Eventually, things have a practical point of view, and they have the secure pieces of code that show you how you should be doing things, not just the words, but the code. What I did was I read some of the guidelines, I read all the pieces of code that I could, and I performed a manual analysis on them to see what kind of vulnerabilities I could find over there. So the coverage was as much as I humanly possibly did, and it was my point of view. I'm sure that if anyone else checks this in the future, I'm sure there are other things that I didn't notice. There may be over there. So I originally thought about how I was going to check for this, if I was going to use an automated tool or not. I'm not very good at that. I never know which one is the right tool, but I basically started looking at the code and see what was over there. The main thing that started this was a couple of years ago. I did a defense framework for server-side code, and I created something that ideally was going to protect other people's code. And to prove that it was useful, to show people that this is really, really secure, what I did was I grabbed the most secure pieces of code that I could find. I put my defense over there, and I tried to break the secure pieces of code. I didn't want to use a framework that was broken. I tried to use the most secure piece of code that was out there, break it, and use my defense code to try to protect it. So I realized over there are bugs in secure pieces of code. And this year, on April, just before I decided I was going to do this, I received an email from a customer that they said, please ask the vendor to point to an industry-accepted guidance such as OWASP in this area. I was a little bit pissed off about this. What happened here was Mostly I'm a security consultant, and I'm also a developer. In this case, I reported a vulnerability that it was a type of bug that it hasn't been reported in the past. It's a type of vulnerability that for me was new, and I was presented that to the client. And since the client couldn't find that in OWASP, they said, okay, this is not backed up by the security industry, it must not be real. I disagree. I have written things for OWASP. I haven't decided to write about this because I don't want to. People write about things for different reasons. So the goal for me with this is that create awareness of what may happen with these guidelines. You might find that they may have mistakes. I believe that's what they are in most of these scenarios. They may be backdoors. A year or two ago, I was talking with another consultant that works with me. He found some weird things on Wi-Fi devices. And he wasn't really sure if they were backdoors or they were mistakes. Sometimes when you don't see the word backdoor, you're confused whether is that a backdoor or is a mistake. Just as it happened in 2003, when they put these lines of code in the Linux kernel without putting any more information about what this was. And they realized that this was not backed up by anyone else. And one of the main things in here is that there is something in here, in this piece of code, that is a backdoor. You could say it was a mistake, but it was definitely a backdoor because they couldn't trace who was the person who did it. And it's about this equal in here. Instead of having two equals to make a comparison, they put an equal, and they were assigning the UID 0, the root user, to the current user. So if you send a message to the kernel with certain flags, you will become a root user. This was something that was introduced in the kernel. They tried to put it. Someone noticed. They remove it. But it didn't have the word backdoor, but it's clearly a backdoor. Nevertheless, these things, the guidelines, the secure code snippets, they are really important. We need them, even though they may have mistakes or backdoors, we don't know. What I did in this presentation was just to apply the same guidelines to the guidelines, and eventually they started to show different levels of errors. The first one, I only have one thing for this one, is NIST. NIST, I'm sorry I have to read it because I don't remember most of the definitions of them. This is a non-regulatory agency of the United States dedicated to improving software assurance. Software assurance indicates that software is free from vulnerabilities, either intentionally designed into the software or accidentally inserted at any time during its life cycle, and that the software functions in the intended manner. NIST has tons of things to review, but I wanted to see only code because this was a time effort approach that I was trying to take. I came across a website that NIST has. It's called Samate, or I don't know how to pronounce it. I don't remember what was the acronym for, where they have a lot of code. I think that nowadays this is not maintained anymore. There are barely any examples that have been put in the last year or two, but it's still out there. And what they present is they show you this is a piece of code that has bugs, and this is the solution to that piece of code that has bugs. So they have some sort of something called PHP include problem. They wanted to solve something here where people will not be able to perform a local file inclusion or remote file inclusion by giving the code the possibility of loading any type of page. Supposing that, for example, they receive a parameter called name. Oh, in here? Probably has to be here. In here. The page would be a parameter received by the user, and depending on the name of the user, they would depending on the name of the page, they will return the name of the page or something else if it was not one of the listed in here. That's okay, there's not an issue with that. The problem is about the file extension. Normally, this is one of the things you love to see if you're a penetration tester. If you see an inc file, you will likely be able to see the contents of them. So I believe the suggestion should be in here to use the same type of file extension that the language is using, because otherwise it is likely that this code will be shown to customers if they're accessing directly these files, which is not ideal. So you can slowly start to build up something in here and how this grows. We have a completely different scenario here at OWASP. These are the two different approaches that you may have when it comes to people saying how you should do things. NIST, a government agency where no one can say anything contrary to what they say. And then you have OWASP, which is like a Wikipedia of security guidelines that is created by the people and maintained by the people. At least I read Wikipedia every day of different things, but this is the kind of secure coding guidelines that you have to quote with careful, because anyone can change it at any given time. I decided to review, you will find that on the slides at the bottom that are the links from where I took these things. There was a source code review guideline provided by OWASP that had a lot of different things that you should do, some with code examples, some not. In here it said that you have to make sure that the usernames or user IDs are case insensitive. I'm not a native English speaker, but when you learn another language, you have to be sure that you understand the difference between when something is mandatory and when something is not. Making sure that something should be like that is a mandatory statement, and I strongly disagree with that. And from a penetration test point of view, this is a problem. If users are aware that this is a case-insensitive system, and you're trying to brute force this, what you will see is that, let's say that you have 10,000 potential user accounts, admin, root administrator, you don't know all the names, but you know that eventually it doesn't matter how you put all the letters because they're going to work. If you have the username master with a capital M or a lowercase m, it would be the same for a case-insensitive username. If you're trying to brute force this, most of the system will block users after 3 incorrect passwords. So if you're trying to brute force this system with just 30,000 requests, you will be able to eventually break some into a potential account. I know that this is like this because I tested in the past. I know it works. It's awesome. Most of the cases, this happens for all the systems. They have to be case insensitive. However, if you're able to use case-sensitive usernames, if you're creating a system that requires you to check for capital or lowercase letters, the combinations when you're trying to brute force the same scenario using up to 6 letters, it's almost 2 million requests. The difference is quite big. So, and this grows exponentially. The longer the usernames, and if they are case sensitive, the longer the bigger the amount of requests that you will have to make to try them out. So making sure that this works like this, not exactly sure that that's the best approach. They have 2 versions of the source code audit guidelines at OWASP. One that was written in 2008 and one that was written 8 years later with some of the same examples. In here, they were trying to, I don't remember what they were trying to teach, but the problem is that they have an exception in the try-catch block. That shouldn't be the idea. And something else, even though it says this is a Java try-catch, this is netcode, this is not Java. The problem here lies within the catch block. This is a common mistake. It has different types of problems. The main one is that when you're using that, the console write line, it would be ideal if someone read in the documentation that it's likely that this could throw an exception. 4 years ago or something like that, I reviewed for the first time C# for a big renowned company, and I didn't know how to do it. I was not very familiar with it. What I did, I read all the documentation about it to see what kind of exceptions they were going to throw, what were the possibilities for an attacker. Exceptions are everywhere, and if you put them within a catch block that it may throw an exception, that's not good. I don't even want to spend too much time with this, since these may be common mistakes when they write, you should be doing this, or it may not, because again, this is a government defining something that says you should be doing this. However, it has collisions, SHA1, so don't do it. Or not specifying the version of TLS that you should be using, which again may be a problem. But I really wanted to focus on the code. So I tried to spend more time where the real code lives, and I think it lives in two places where the people who check the code should be using these guidelines. The Common Weakness Enumeration is an organization sponsored by the United States Computer Emergency Readiness Team. These were, you may have seen it outside this room. The Computer Emergency Readiness Team of Austria is outside this room. It defines a set of software weaknesses which enumerate design and architectural vulnerabilities as well as low-level coding and design errors. I believe the Common Weakness Enumeration is super awesome, but I found a couple of issues that are worth the attention. Whenever you see something with this color, with this purple, blue color, that is good code. You want to see this type of code when you're reviewing something. They show you a bad example, this is the good example. This is the good example in Java. So in here, they're talking about the missing initialization of a variable, and this is how you should do it. So the important things in here is that you have a bank manager that is receiving a username, and that username, eventually you try to get the user from the database. This is written in here. It retrieves the user. So what it does is it receives a user, let's say non-existing user, in here, in here. Then it passes non-existing user in here. It is receiving here. And since non-existing user doesn't exist, it may return a null, which would be checked in here. Now, here comes the first problem. If you see what they're doing here is they're checking the username first, and if they cannot find the user, they will say, okay, I couldn't find it. If they were able to find the user, then they would check the password. So we have the first issue in here. They're disclosing valid usernames by the timing. How do they do this? Suppose that you put the username non-existing user and you put the password whatever. You will end up in here eventually with the message that you cannot find the username. And supposing that has the final user cannot see this message because this is printed on the console, eventually it will receive the variable here that the user is not authenticated with false. If the user is able to put an existing user, let's say admin, with a correct password, they will eventually end up in here because they will be checking the user admin exists, so they will be checking if the user admin has the right password. So the cycles needed to execute this, whenever you put a correct username, it requires one more cycle to check this. So you may eventually check for valid usernames because they will be disclosed, because checking a valid username takes more time than checking an invalid username. Checking a password and checking a user should be done at the same time. If it is not done at the same time, you need to introduce a level of timing randomness in here so the user doesn't know if their user was existed or not. Then we have lame mistakes like the error may not be logged because this output may be closed or may not exist at the moment, and you may be able to inject things. So if you write the username, cannot find username, non-existent, new line and something else like user was granted access, you're introducing mistakes in the logs. Not the greatest thing. Then we have things that are pretty much more basic, where you know that something is running here. Simple SQL injection in the recommended piece of code of how you should deal with expose dangerous method or function. In here, what they're trying to say is use private. We are all aboard with that. But don't put it like this. Use it as a prepared statement or something that is not proposed to injections, because this will. When I first joined IOActive almost 8 years ago, I started analyzing code almost right away, and I haven't stopped since then. And I had a poor basic understanding of how to check for code. And the first thing that I did was to check the secure coding guidelines of CERT. This is a non-profit United States funded research and development center that creates the most magnificent pieces of code that show you how you should be doing things. But they may have errors as well. This is something that is called do not allow exceptions to expose sensitive information. So they try to do a couple of things in this example, and things in here will get a little bit more complicated. I'll show them with an example. In here it says that failure to filter sensitive information when propagating exceptions often results in information leaks that can assist an attacker efforts to develop further exploits. An attacker may craft input arguments to expose internal structures and mechanisms of the application. This is a complex way of saying that you shouldn't be allowing certain people to access sensitive information. So they provide with an example of this compliance solutions implements the policy that only files that live in this directory may be opened by the user, and that the user is not allowed to discover anything about files outside this directory. Let me show you how this works. Pay attention to a couple of things. This is the directory that they're using. It's in here. Okay. So the first thing you need to do to run this example is to set the application data where this is where the home path that I referenced before is. Instead of using home path, since I'm using a type of Unix environment, I will be using this directory, which is one of my fake users in here. So what I will try to do is to access the .bash rc that is in that directory. What I just did was to access a file that was located in here. So the example, what it shows, wow, you cannot see it. Okay, if I select it, worst. I have an idea. In here. So what I changed on the previous example, I changed a couple of things. I changed the path because I'm in a Unix environment. I put it like this. And then I changed the error message just a little bit, just to identify where I was hitting them. I put a 1, I put a 2 in here, I put a 3 in here, just to make it more verbose of what was this about. So let me show you something. These are my users. Okay, as you cannot see, okay, you can see in the video it says test, and here it says test 2. I have two users in here. One is called test and the other one is called test 2. So if you want to access, for example, let's go back. If you want to access, if you want to go back and try to access this file, you're not allowed to do it because you're trying to access something that is allowed, it's outside the user test directory. However, if you try to access the other user, you will be able to do it. But why does this happen? In here we have the bash rc file that belongs to the test2 user. This is the same as doing this. Okay, I'm just showing you this file instead of the first user file. Why does this happen? Because of this. They shouldn't be using their start within here. Or if they're going to use this, they should be putting a final slash over there. Because you're able to access all the directories that start with that string. You're able to access home path and home path fail. I was able to access the test directory and the test2 directory. So they're not restricting entirely the possibilities. You're able to access other directories outside the home path directory. There are other things in here that are minor. So you're able to, these guidelines tell you, you shouldn't be printing exceptions, you shouldn't be allowing exceptions to happen. And the first thing you get when you run the example is that if you don't put any arguments, you will get an exception. So it doesn't handle all the exception, and it's not checking the arguments. They should be checking the content of that before doing something. And finally, the error may not be logged. Just as we saw previously, it's the same type of thing. They shouldn't be doing this. And within the same guidelines, it says, do not use system out println to write errors. This is the second mistake that I'm going, or error or whatever, that I'm going to show from CERT. Do not operate on files in shared directories. So when you're checking code, one of the first things you want to do is to know that the program is not writing anything on a temporary directory or in a place where other users can modify those files. You want the programs to write all the information, the sensitive data, within a private directory, in a place where no one else is going to modify it. So to prevent vulnerabilities, a program must operate only on files in secure directories. This is perfect, this is mandatory, this is important. And you have to pay attention that file links can be swapped out and may not always point to the internal location. As a result, file links in shared directories are untrusted and should not be operated on. Makes a lot of sense. You should be doing that. This is the piece of code. I'm going to focus on the links in here. This is the piece of code that checks the links. And this is the demo that tries to break that. So in here I have the program that they made. Again, I introduced some minor modifications to it, just to know in which line I was doing what. I will show you what I'm talking about. I am writing things that were commented. I'm writing them just to be sure that I'm showing you the error that they intended to show. You shouldn't be disclosing this to the end user. I'm just doing it for the purpose of making this example more clear. I put that line over there, this line over here, this line over here. So this is what we're going to do. You have the link in here in case you want to check the code. So the scenario that I'm proposing in here is that I will have a file called extract data on the temporary directory. You shouldn't be using this file because it's on a temporary directory. And I'm going to create two links that are going to point to this file. I'm going to create a symbolic link, and I'm going to create a hard link. And this is how it looks. I have the extract data file in here in the temporary directory. I have the symbolic link in here, and I have the hard link in here. These are all the ways that you can access that file. So the first thing I'm going to do is to try to access the temporary file. The code will say, this is something extra that I printed just to make more clear what I'm trying to access. In OS X, the TMP directory is in fact in the private TMP directory. So the first error that I'm going to see is that this is a symbolic link. I shouldn't be accessing this. At the same time, This is a temporary location where everyone can write. I believe if I put this, oh, okay, I get a different error in here. Now I'm trying to access this file, and the error says someone else can write files in here. This is a temporary location. You shouldn't be accessing that. This is not secure. This is what happens when I try to access the symbolic link. When I try to access the symbolic link, I'm going to get twice this error. There are two links in here. First, this link in here points to TMP extract data, and TMP extract data access private TMP extract data. So that's why we have two of these messages in here. Eventually, I have the error that the file is not in a secure directory. Oh, I forgot to do something. I wanted to write a couple of things to that file. I'm going to write that, I'm going to write that, and I'm going to write that. What I just did is I introduce information into this file directly using the symlink, using the hard link. We have all the information in here. All three ways work to access this file. When we try to access the hard link, everything is okay. Why is that? Why do we reach this instead of the other error? This is because a tiny thing that they didn't check when they wrote the code. When they check for the links, they check for symbolic links and not for any type of links. It was a tiny error. So what this means is that you can create a hard link within a directory that is not secure and access those files. And this is the kind of errors where you wonder if, was this a mistake or was put intentionally? Because this is how they propose that you should access temporary files. And if you're writing a program, you will eventually write something to a file, ideally not to a temporary location. And you should be using, they're proposing that you should be using this code. In case the previous demo didn't work, this is a brief example of how it works. This is the creation of the symlink, the creation of the hard link. This is how the symlink looks like on the hard link over there. When you check the symlink, you get that this is not in a secure directory. And when you do the hard link, you are able to access the file, and there are no errors being printed, which is not good. So how did this happen? Where do we go from here? So writing secure code is tremendously difficult, tremendously difficult. We do a number of things to write secure code. We use secure coding guidelines. We use secure code snippets. We use static source code analysis. And we use people to check for the code. That's super important. We need to use all these things. What we have seen in here is that there are different forms of errors that we have seen across the different people who create guidelines. We have two extremes. We have NIST, a government telling you how to do something, and you have OWASP, any random person saying how you should be doing things. And you have in the middle the common weakness enumeration that quotes other people when they're writing their examples and how you should be doing things. And you have the Start Secure Coding Guidelines where they quote other people and they allow other people to put comments. I believe that this one is the best model, even though it has issues, but they're public. They can be reviewed and you can write that down if you want. These issues can be found over there. No one of these issues has been reported, so they may eventually will continue over there. I still believe that people being able to put comments and saying what they think about this is absolutely mandatory. The same way in Argentina, there is a lot of controversy because they're trying to implement the electronic vote, and that has proven to be a mistake because, at least a mistake when it comes to closed source, because it has been shown that it has errors, and still the government is pushing that topic to be implemented. Even though other people cannot check what's inside that code. And that's not the ideal scenario because someone may put something in there beneficial for someone else. So how do you write the secure code? I'm absolutely happy to continue using the secure coding guidelines, and I believe that we should promote them. But again, as any other type of software, they may have things that we may not want to see over there, and we have to pay attention of what are we going to recommend. Eventually, we will have people checking out the code, and that's going to be ultimately the final solution. Having multiple people checking the code, whether it is for writing a guideline or whether it is for checking the program that you're writing or you're reviewing. Anyone has any question? Yes.
Are they being fixed, or did you report these, and how does one actually get to report these and get them fixed?
So the question is how you should report them, and if they have been reported, these issues. I believe that in some scenarios where the guidelines are open, like in OWASP or in CERT, you may be able to do something about it and write something about it. I don't believe it would be possible to do that for the common winnings enumeration. I would love it to be possible because I think it's tremendous what they have done. It would be great to have more people work on that, and I'm sure the government will not allow that. I didn't report any of this, so, and I'm not planning to show this presentation again. So enjoy. Any other question?
There's plenty of time, so take your chance.
I can skip that one.
It's more like a philosophical question.
Yeah.
On the number of codes on the number of bugs in code. Do you believe it's finite? Because I'm inclined to believe, as we know from war history, that people invent new attacks all the time. And so it may well be that a piece of code that is secure today is not secure tomorrow. Do you believe we can make code secure in that sense, that we can look at it and say it's bug-free, it's secure? Because I believe circumstances change, and we always will see new bugs and new, as for example Spectre and Meltdown have shown, we will see code that was previously believed to be secure to not be secure, and so it's more like a philosophical question. What do you think on that?
So the question is, if I interpret it correctly, it would be that if we will be continue seeing more issues, probably the question is yes, even though we apply all these things. I'm sure the me who checked this code, I have all these things, I read them years ago and I found it to be perfect. When I reread them on a more, from a penetration point of test view, I came across some of these issues. I do believe that these problems are here to stay, and I do believe that server-side applications should try to defend themselves. A major, and I have a practical example of this, of how do I believe that should be done. I believe we're always going to have errors. That's a great thing for the people who were finding these errors or fixing them. A few years ago, I was on a big software company that creates products that are based on RFC using standards. For example, they are checking the HTTP standards. And I was taking a look at the code, and I'm talking about a giant company. And there was a moment in the code where if a piece of is a request, if a request from the attacker or the user was not following the guidelines, they were dropping the request. I strongly believe that that's an awful approach to computer security. I believe that software should try to do something about attackers whenever possible. In particular, in server-side applications, you must start building the scenario of someone attacking you when you're violating a standard. You cannot do that on client-side applications when you have the software running on your computer, but when it is in another computer, you can start building a profile of who's accessing you. If that person is violating a standard, that's not normal. I do not expect my customers to do that because browsers are sending, ideally, a restricted amount of things. And I believe the software industry is not putting a lot of effort into this matter, which allows a giant amount of bugs to happen remotely that could be stopped. Yes.
Thanks. It was an interesting talk and some interesting ideas. I want to go back to the symbolic link, which is really useful since you have it there, right?
Oh, okay.
Is this really the fault of the requirement? Is the vulnerability in the requirement, or is it a fundamental problem with the way that the library is being built and the OS responds to the hard link? Because it's not necessarily, you're taking it from a perspective of this requirement says that you shouldn't follow symbolic links outside of your secure directory subdirectories, right? But the fact of the matter is, if the OS isn't responding properly, you're not really violating that requirement. It's the OS that's not doing its job in the right way, or it's the library that you're using that's not fit for purpose.
I will give you an answer that first I'm going to talk about something else. I was asked to build a piece of software by a person who doesn't know a lot about software. I created that piece of software, and I didn't know who was going to access what. So as any kind of application, it has users, groups, permissions. I didn't know how they were going to be, but it was completely open. You could create a group of admin users that would have a lot of privilege, and an anonymous user wouldn't have any privilege by default, and you could create other groups in between with different types of privileges and so on. Then other people in the same company created another application that was going to be put right next to the other one. A month or so ago, I asked these people, so how do you create the permissions and so on here? What? I rephrased the question, I did the question 5 times. It was a really awkward conversation because I couldn't get to the point of how they do it. I show you, give me a moment, I will show you. You see this website in here? In here, okay, create this group, and I can assign these permissions if they want to read this, or modify that, or delete this. How do you do it? And they told me that was not a requirement, so I don't do it. What do you mean you don't do it? No, I will eventually implement security on top of this. And the permissions. So there were no permissions at all in this application. An application that was supposed to interact with clients, just like every application that is out there. It needs to interact with different people. So the argument was that was not a requirement. When I received the original requirement for the people who made this person didn't know how to put into words what he wanted. I just leave it open to provide multiple paths. And then you have the opposite approach where you don't provide any paths at all and anyone can access everything. That system allows anonymous users to read, write, and modify information on the system. So who was the person guilty here? The person who didn't know anything about software that wanted a piece of software created, or the person who developed that piece of software? I believe the problem lies on the person who creates the piece of software. What it should have done is to create something that is going to be maintained in the future, and it has security built in by default. I believe that programming languages are the ones to blame in here. I believe that it shouldn't be the developer the one who should be checking all these things? It should be the language checking all these things. As we saw in the past, 10, 20 years ago, when we were creating programs in C or C++, and we're seeing overflows all over the place, then we eventually switched to higher programming language, where we should have those checks automatically within the code. Like you will see in Java, you wouldn't have the overflows, you will have other type of bugs. But I do believe that the code should be implementing the security, and the code should be restricting by default the possibilities of what the developers should do. I think the language is to blame in here. I think we should go towards languages that are more secure and that are easier for developers to implement. Don't put the guilt on the developer, put the guilt on the language. And I'm not saying that Java is bad, it's beautiful. But Java should evolve into something else, perhaps.
Just as an addition to the hard link, symbolic link thing, might that be a particularity of HFS Plus or APFS, the macOS file systems? Because many file systems don't allow hard links on directories, so that developers might not even know that this is possible and be a very platform-dependent thing, so they did not probably know to check for this.
I don't know if I check this in Linux. I only check it on OS X. But I would expect, it is the same behavior in Linux.
Time for one last question? Yes?
I think it's not enough to have good guidelines. I see the biggest problem in the lack of good implementation examples, because most of the time you have some documentation and you don't have really good examples. You find some stuff on the internet. You don't know, is it reviewed? How good is this? Are these fragments? Also, most of the time they are not language specific. So I think we would need really good implementation examples, which are reviewed.
Something else that I found in the last year, important company that I cannot say a lot of things. I don't want to. If I say what this company does, you will know it's going to be narrowed to 2 or 3 companies. I shouldn't be doing that. But it's an important company for the security of any company. They provide a piece of software that is critical, that can be implemented remotely within the company. Within the software, we were reviewing the software, and I came across, when I review code, I try to check a broader aspects of the code, starting with the higher risk issues, and almost immediately, as soon as I started, I came across the possibility of evaluating code server side within the software. And I was like, this is not happening. They don't have this. And I started to analyze why that was over there. And it was part of a horrible implementation that someone on the internet did. And the developers of this company put the library within the code, a code that was made years ago. And it was evaluating instructions from the customers, server side. It was an allowed code execution, server side. When I reported this, the first thing that I heard from the company is, if we don't have a proof of concept, we're not going to fix it. And that's probably the reason why that piece of code was over there on the first time, because if they were doing static source code analysis, they weren't checking for that. And the developers, sometimes they may freely put other people's code. They may copy and paste, or they may introduce those libraries and introduce those bugs. This has been in the code for years and no one noticed. There were other bugs in the code that I reported. On a previous project, the company contacted us and they were terrified because something was about to become public that was going to really affect the image of the company. And they wanted us to analyze the second bug that a contractor had reported them. The first bug was horrible. They fixed it, and they were concerned about a weird cross-site request forgery that was possible to attack them. We checked, me and a colleague, and I came across something that it was blatantly more obvious that was going to be exploited. I reported the analysis of the cross-site request forgery with a medium risk because I couldn't believe that anyone was going to exploit that. And I put something with a higher risk saying, you're going to be affected by something else, by this issue. 8 months later, someone else went public with the issue that I reported that they didn't check because they were fixed on that issue. So sometimes you have security people within companies or developers that are fixed of what's the best type of root, and there is nothing that heals those people. So that's, I mean, the vulnerabilities are going to be injected in different ways. Thank you, everybody, for coming.